Okay, we look at the process of factoring 2x squared minus 5x minus 3, and then using that factoring to solve the equation 2x squared minus 5x minus 3 equals 0. Okay, so we first make an attempt, okay? We know that 2x squared, if we're factoring over the integers, is going to give us, it's going to factor into 2x and x, so that we're going to have 2x plus or minus some number and x plus or minus some number. Now, the numbers we use over here have to be factors of -3, again, if we're factoring over the integers. So the factors could be -3 and 1, or 3 and -1. And of course, the 3 could go over here or over here, with the 1 going in the opposite binomial. Okay, so let's just try, just to get a feel for this. 2x minus 3 times x plus 1. What happens? Well, if we multiply that out, we see we're going to get a -3x plus a 2x. Well, -3x and plus 2x gives us doesn't give us -5x. Okay, it gives us -x. So that's not very promising. Now we could try plus 3 here and minus 1 here. Well, that would give us a plus 3x and a minus 2x. That would just give us a plus 2x. So neither of those works out. Now between here and here, I've just, in answer to some questions, written out the product of these two terms, or binomials. And then here I wrote them out even in more detail, being very explicit about the distributive law to be sure that we really had that right. But we tried this, and that doesn't work, so I put nope down here, so now we're going to try something different. Okay, we're going to try the 1 here and the 3 here, and we're going to use a -1 and a plus 3 just to see what happens. Well, if we put -1 here, we're going to get -x. Plus 3 here is going to give us plus 6x. That's going to give us 5x. Now, that's close in the sense that we got a 5 here, and we need a 5 here, but this 5 has the wrong sign. But these two have, if we switch the signs of these two, though, that's going to change the sign of this one. So that's what I mean by we're close. If we just change the signs of the 1 and the 3 here, we get 2x plus 1 and x minus 3. And we can confirm that that works. We got a plus x and a -6x. That's going to give us -5x. So now our equation becomes 2x plus 1 times x minus 3 equals 0. So we have a product of two factors equal to 0, meaning that one factor or the other has to be 0 in order to attain a solution to this equation, in order for this side to come out 0. Okay, so let's see now, 2x plus 1 equals 0, we get x equals -1/2. But we could also have x minus 3 equals 0, which would give us x equals 3. So these appear to be our solutions. Now we can check, we can substitute -1/2 for x in our original equation. We get this, and this works out. 2 times -1/2 squared is 2 times 1/4, which is 1/2. This multiplies out to 5 halves. 1/2 and 5 halves adds up to 6 halves, which is 3, so that when we subtract 3, we get 0. If we plug in 3, you can also check that we get 0. So we have our solution to this equation obtained by the process of factoring. Okay, here we have x minus 3 quantity squared equals 36. And this is the equation we're trying to solve. Well, this equation can be solved very directly. We have the square of something equal to 36. Well, if the square of something is 36, then that something is either 6 or -6. What's that something? That something is x minus 3. X minus 3 is squared, we get 36. That means x minus 3 either has to be 6 or -6. Okay, now we can write that a little more formally. X minus 3 is going to be plus or minus the square root of 36, which in this case gives us plus or minus 6. So now we have either x minus 3 equals plus 6 here, with solution that's very simple, x equals 9, or x minus 3 is -6. Solution is x equals -3. we could plug these numbers back in. If we plug in 9, 9 minus 3 is 6, 6 squared is 36. Plug in -3, -3 minus 3 is -6, square that, again, we get 36. So this process works just fine. So when we have a perfect square equal to some number, whatever's inside that perfect square, whatever quantity we're squaring, will equal plus or minus the square root of that number. Okay? Now, another question. 4x squared plus 5x minus 1. Solving this using the quadratic formula. Now, most people at this stage of their first college math course aren't going to remember the quadratic formula, but they'll remember having used it, and they'll recognize how to use it in a simple example. So that's what we're trying to provide here. So the quadratic formula says that ax squared plus bx plus c equals 0 if and only if x equals negative b plus or minus the square root of b squared minus 4ac, all that divided by 2a. Now that formula is actually proven very easily using a process called completing the square, and we're going to see that process in a minute, but we're not going to try to do the proof of this. I might do an extra video where I show how that works out, but right now we don't need it. We just need the formula. So here's the formula, and I do expect you to know that formula, be able to write it down at any point from now on for the rest of your life. Okay? At least for the rest of this course, and hopefully if you learn it well in this course, you will remember it for a long time. Okay? Okay, well, now for the given equation, we recognize that if the equation is in this form, then a, which is the coefficient of x squared, is 4. B, which is a coefficient of x, has to be 5, and C, which is the number you got left over here, has to be -1. So we can write this down. A is 4, B is 5, C is -1. Okay. Then, this is true if and only if x is equal to one of the expressions you get here, either the plus or the minus. So we write this down. Just substituting 5 for B, substituting 4 for A, substituting -1 for C, we get this. And that should be very clear to everybody. Then we multiply things out. Again, very easily done. 5 squared is 25. 4 times 4 times 1 is 16. We have a negative here and a negative here. That makes our 16 plus here. And 2 times 4 is 8. So 25 and 16 is 41. So we end up with -5 plus or minus the square root of 41 divided by 8. And we can separate that out. Square root of 41 is not an integer, so if we want the completely accurate solution, we're just going to write it as the square root of 41. So we could write this as -5/8 plus or minus the square root of 41 over 8. Now, this can be approximated using your calculator. You would have two answers, one corresponding to the plus, one corresponding to the minus. And I'm sure that just after doing a couple of these, you'll remember what you've done in your prerequisite courses. This won't give you any difficulty.